Hello, good morning, good afternoon, good evening, the learners. Uh, this topic of compounding and discounting has been misunderstood for times and memorial. This is a basic concept, and trust me, if you don't learn this concept, it's very tough to understand the concepts of finance exclusively, concepts like time value of money. So, this is the basic foundation upon which the entire concept of time value of money exclusively in finance is relating. So we'll just begin with this, and basically the entire concept revolves around the two techniques, compounding and discount. In order to begin with this, I would like to recall the concepts of compounding techniques. The concept is, however, not very new. Uh, the formula of compound interest, the left hand side has amount, but in case of compounding we replace this by future value, and the concept of principal amount, as it happened to be in compound interest formula, is now the present value. So rest all remains the same, and hereforth we begin with this concept of compounding. In compounding, this was the first concept wherein we had only one inflow. Had it been a situation when there are n number of inflows, and the time span during which we are receiving, or maybe we are paying some value, some cash flow, some cash inflow, some cash outflow, so all that needs to be found out as the future value. So that's how we generalize this formula as a summated value of the present values we are receiving at the end of first period, second period, third period, and so on till the time period. Henceforth, we do one thing, we draw a timeline. As and when we get to see a complex or even a simple problem for the time value, or maybe the concepts of compounding, the very first thing we should be doing is to plotting the entire information on your timeline. Here I begin with this timeline. This timeline actually shows you what inflows or outflows are being made. Before we proceed with this discussion, I would like to walk through a very simple anecdote that talks about, can you ever have an option of getting your salary or maybe getting your income today and 1 month hence? What would you choose for? Out of the two options, if your employer or your debtors, they are ready to pay you today, we are always ready to accept it. Why so? Because money tomorrow is never equivalent to money today. That's the basic idea, even if we are not concerned with this topic. But yes, in case of money or inflows, we always prefer to have payment as soon as possible. So this thing is very much clear in your mind already, that money today is something you would always like to prefer than money tomorrow. So let's begin with this. Here you have a series of inflows, 500 rupees in the first place. In the second year, you get to have the same amount. Third year, 4600, and in fourth year seems to be a good rainfall for your maybe profitable project it is. So this works out to be how much? 10,000. So if at all you are thinking of what is the future value of the entire project after the end of fourth year, is it really 500 plus 500 plus 4600 plus 10,000? Actually no, because money received today is somehow different from money received after 1 year, after 2 year, after 3 year, and so on. So the first concept you must make sure here is, these inflows, these four different inflows, are not supposed to be added right at the face of it. We need to make one transformation, and that transformation is, what will be the value of these inflows at the end of time period 4. So we'll do one thing. The first inflow, we have 500 rupees. This 500 rupees is to be transformed, or maybe simply we are putting it to some bank account, or maybe for some set of income that is yielding you some 10%. So thereafter, at the end of this fourth year, you are having interest for 3 good years, because From 1 to 2 year, you have one year of interest. From 2 to 3, another year. From 3 to 4, another year. In totality, you have here 3 different years. So this actually 500 is now 665 rupees and 50 paise. Followed by that, the very next year earns you the same amount of 500. But is this 500 equivalent to the first year's 500? Outrightly, no. This is actually equivalent to 605 rupees, because here what we are actually interested is, we are interested to find out the value of all our inflows at the end of fourth year. So in this case, since you are receiving this 500, its value, you are receiving this 500 at the end of second year, its value is certainly less than what you received in the first year. That's here 605 rupees. Third inflow, somehow better inflow, 4600. Here you have 1 year time span. This could be reinvested or saved. So we are making another interest on this, that is 1 plus r. The very same formula of compound interest, 1 plus r raised to power n. So here we got something like 5060 rupees. And the last one, 10,000 rupees. This 10,000 rupees is somewhat the day we are receiving this 10,000 rupees is actually the day when we are calculating the entire inflows. So we are not supposed to multiply this with any set of interest. That's how this 10,000 rupees remains intact as it is. So all the 4 inflows are they are added here. So now what we have truly 16,330 rupees and 50 paise. Uh, in the previous question, we had one thing that was different inflows, okay? But had there been a situation where you would have same inflows for the time period n at the given rate of interest, then what? Would there be some change? So basically, we are doing one thing, we are replacing our last 2 payments which we had in the last question by again 500 itself. So this 500, I'm sure nobody has this doubt in mind that we if asked this question, what is the total income from this entire project, nobody is now going to say it's 2000 rupees, certainly, since 500 received each year cannot be added. Okay, so thereafter you have one more thing. I'll just discuss about this very shortly. For now, these things are dealt in the similar methodology what we did in the previous question. This 500 is multiplied by 1 plus r raised to power n. Okay, so these are the four different inflows, and when you total them, this turns up to be 2,320 rupees 50 paise. So, however, we are repeating this exercise with different inflows, but we can still simplify our calculation. How? We have one future value NUT factor. In tables, this is either known as CVAF. So instead of repeating this exercise these many times, we can do one thing. We can multiply this 500 by 4.641. So now we have the same number that turns up to be this. I'll discuss about how to calculate these factor tables in my next videos. So a generalized formula is what your inflows or outflows are. You got to multiply that by NUT factor at the rate r and time span n. These are some questions. I am sure you can now solve them, and what you have learned and what you have missed will be revealing you after you face these questions. So let's begin with the next methodology. The next methodology talks about the discounting technique. Discounting technique is nothing strange or nothing new kind of concept. This is just inverse of compounding. I'll begin with the same formula, the formula of compound interest. We had the two things that we discussed. Now we are doing one thing. We are finding out the present value, or in the conventional formula we are finding out the P, the principal. So the two terminologies have changed. A and P are now FV and PV. We are just resettling our equation, and now we have arrived at present value to be equivalent to future value divided by 1 plus R raised to power n. This is the entire series of all the cash flows we have for time span n. So now we are discounting them. The concept of discounting is nothing but dividing them by 1 plus R raised to power n. Let's have the same question. In this question we have to do one thing. All the inflows are to be divided by 1 plus R raised to power n, so that you can find out what is the value of this 500 rupees received after 1 year now. I repeat, what is the value of your inflows now? Now your inflows stand to have what value? If they are making you a profit or an inflow of rupees 500, 500, 4,600 and 10,000 at the end of first year, second year, third year and fourth year. You want to find out what is its value today. So certainly and blindly you can say that what is 500 rupees after 1 year is going to come out to be something less of that price today because you are discounting. So next inflow is 500 rupees. You are again dividing this by 1 plus R raised to power n. Third inflow for you, 4600 has to be divided by 1 plus R raised to power 3. Last inflow, 10,000 divided by 1 plus R raised to power 4. So in total, what you are actually receiving here is 11,154 rupees now. This is the value of all the future inflows today. So similarly, you can also have a concept where same inflows are accruing and you got to find out its present value today. 3,500 till 4 good years. You want to find out what is the value of this 3,500 rupees you are earning every year for 4 years, and you want to find out its value today. So you got to do the same exercise. Divide the respective inflows by 1 plus R raised to power n, and then you will come to know what does it stand to have today. Yes, you also have another methodology that can ease your calculation, that is to find out a PVAF factor. This factor comes out to be 3.17. How you need to ascertain this factor is nothing but a combination of rate and time period n. When you are given these two, you have a readily available table, and if you want to calculate this, I'll be discussing this in my next video. So the same calculation, but you have somehow eased your number of steps. You are outrightly multiplying 3,500 by 3.17 and coming out to be the same total amount, that is 11,095 rupees. So a generalized formula for this is divide all your cash flows by 1 plus R raised to power n, or simply you can do one thing, multiply your cash flows if they are equal every year by PVAF factor. Let's experiment these two questions. I'm sure you can find them very easy now. I'll just I'm here to conclude the entire discussion I had right now. When given for the same inflows, you can find out its present value as you are doing it in the second half of this slide. Here we are doing one thing, we are finding out its value today. That comes out to be 11,154 rupees. Vis-a-vis, you can also find out the future value at the end of time period end, that is maybe 4 in our case. So that turns up to be 16,330 rupees and 50 paise. So I would like to only say that these two techniques are just inverse of each other. Okay, however, we are making different inflows over different time frame. We can find out its present value now, and we can also find out its future value at the end of time period n. And obviously, just remember a rough concept about it. When you are finding present value of anything, it has to be less than that inflow, actual inflow. For example, this 500 in the first year is as a present value hardly 455 rupees, and for the second year 500 rupees is now today stands to be 413 rupees only. Similarly, if we are finding out the future value of any amount, any money has to be more than its present value. So that's end of the session, and I